Good morning. What a beautiful place and so many beautiful people. It's an honor to see so many here so early to listen to me for 40 minutes. That's actually a bit humbling, to be honest. I mean, you know me, you see all my titles there. Sorry about that. But I don't know you very well. So follow me, just a little exercise. I just want to know a little bit about you. How many of you are in the creative industry? Just clap your hands. Clap your hands. Wow, that's a lot. How many of you are sort of more in the tech sector? Clap your hands. How many of you work in any field related to climate change, environment, etc.? Ah, good. You're in for a treat today. How many of you think that super intelligent artificial intelligence is one of the biggest threats to humanity? Clap your hands. How many of you think that climate change is one of the biggest threats to humanity? Interesting. Well, nothing to clap on, but of course. It's a long talk. I have a lot of slides, but I want to offer you three main things. First of all, I want to offer you one insight. I think something that frames the innovation challenge that we're facing in a new way, that I hope that you see this is where we need tech to take us in the future. Another point is a provocation. And the last point is, of course, a call for action. Because I think that people here in this room, especially in the creative industries and the tech industry, have a lot to offer to the challenges we're facing, but with the proper framing. So that's what I want to talk to you about today. Of course, there's such a massive hype around artificial intelligence nowadays. This is just one example of many, many examples in journals, etc. Like AI is going to help us solve the climate challenge. It's going to help us optimize things. It's going to make our transport systems more efficient, etc., which is interesting. But I think that sort of focus on artificial intelligence and technology that we're seeing at the moment is very, very limited. A lot of it is about improving modeling. It's about improving predictions. It's about promoting efficiency in different systems. But to be honest, I think that the impacts of artificial intelligence, more data, increased use of robotics, has a much, much deeper implication for us as humans. And I want to offer you just a small example. So I just took this from Wired. This was from 2006. And this was about a journalist whose father was about to pass away in cancer, I think. So what he did was that he interviewed his father and created a chatbot based on the properties, on the way that his father spoke, for him to be able to talk to his dad once he has passed away through a chatbot. So if you follow that conversation, and I suggest you can look this up in Wired, this is an article from Wired, the sort of the conversation that he has with his dad in the form of a chatbot. So for example, hi, this is Jamie, and then the father chatbot responds, I thought I smelled something funny. Well, how the hell are you? I'm feeling stressed out today. I'm sorry. If you're feeling tense, I prescribe a gin and tonic. So this is based on the way that his father spoke. And to me, this was a very emotional thing to read. Like the massive power in simple code to trigger very, very strong emotions in people. And of course, there's a backside to this. Have you ever done like trying to book a restaurant or a flight or a hotel, like in Booking or et cetera, et cetera? Sometimes you go into the computer and then you look into a hotel and then a room and then you see a pop-up window. Have you seen that? And then it says, 19 other people are looking at this exactly right now. Have you seen that? You know, some of these sites, and some people looked at the code behind it, the code was just telling the website to just add a random name, a random number to the number of people that were looking at that site. I mean, that number was not true. It's just like a random number between, say, 5 to 19 or whatever. And of course, that stresses you out. That's the whole intention of that sort of code and how it triggers emotion. So what I find important in my work, I think there are two main insights in the way that I look into this. First of all, without a bias fair on planet Earth. And by the biosphere, I mean the climate, but I also mean the living systems, forests, oceans, living species, mangroves, etc. Without a biosphere, our planet is nothing more than a dead rock floating around on space. So we're fundamentally dependent on a living biosphere to be able to live on this planet. To me, that's so important. The second thing, of course, and that's why we're here, is that on this biosphere, we've created a massive, extremely powerful technosphere. And that technosphere can tip us into very different futures. And that's why we need to think about how to create a technosphere that drives us towards sustainability. The thing is that the technosphere at the moment is expanding quite rapidly, right? And this is just one example. This is one of these promotional videos that you can find online. For example, precision agriculture. The thing with precision agriculture, and you see this in many other fields like forestry or marine extraction, climate modeling, is that we have so much data nowadays. There's so much you can do with data, so much you can predict, so much that you can model, so much that you can optimize. And this is a revolution, I would say, in the making. And to me, there are three main things that you need to keep in mind whenever you see a promotional video like this. First of all, what we're seeing are the impacts of decreasing costs of sensors and decreasing costs for satellite data. So what happens now in the environmental domain and the climate domain is that we have a data explosion. So I'm a scientist. One of the biggest challenges we face as a research organization is how to make sense of all the data that is now becoming available. The other thing is, of course, and that's why the hype around artificial intelligence and deep learning, machine learning is taking off, is that through these advanced algorithms, we can make faster analysis, we can make more sharper predictions, and we can diffuse this information very, very rapidly all over the world, very, very quickly. And the last point I think is important. It's not just about data and algorithms. It's also the fact that we're seeing improvements in robotics. So once you merge these two, robotics and intelligence, actually you create intelligent autonomous agents. This sounds weird, maybe, but this is a reality. I mean, if you just look at EU and investments in the European Union on experiments and deployments of this in smart agriculture or precision agriculture, smart cities, etc., it's taking off. There are big consortia, big investments on this, and not just in the EU. So another analysis that we did, like in China, big investments, multi-million in technical digital agriculture, experimentation on plots of the size of 250 square kilometers. These are not small experiments. Similar things in India, big investments. Africa as well, one of my favorites is probably from South Africa, where there's an institute that focuses on vineyard robotics, only that. And then in Brazil, with Internet of Things, deep learning applications, etc., etc. So this is what's happening in the world. This is expanding. But taking one step back, again, thinking about the biosphere and the planet we live on, I just want to give you a little bit of something called deep time context. So this is the deep time history of planet Earth from a climate perspective, starting 60 million years ago. So 60 million years ago, the planet was about 10 to 15 degrees warmer than it is today. And then over time, it cooled down. And then at some period of time, you see a lot of instability. But then, and this is important, something happens around 10 to 11,000 years ago. Do you see what it is? The climate stabilizes in a way that we haven't seen before, 10,000 years ago. This is called the Holocene. And what you should keep in mind is that we, humans, as a species, managed to blossom because of these stable climate conditions. So everything that we are proud of as a species, democracy, art, our economic system, etc., has assumed or is based on that climate stable phase in the history of planet Earth. Of course, what happens now, and that's why you hear climate scientists and people talking about it, is that we're rapidly moving outside of that stable phase in the history of planet Earth. That is a massive, massive trip into the unknown for us as a species. And this will have impact on everything. I mean, that's what we know. Agriculture, biodiversity, oceans, and our economy in the end. The thing is, and this is another slide beginning from the Roman Empire, is that projection, I mean, we're about one degree above where we should be, and then the projections from the IPCC going all the way up to 6 degrees, that's an extreme scenario, 2100. We don't want to be in that phase, all right? We don't want to be in that scenario, in the bad scenario. One of the worrying things, of course, is that it's not just about emissions of carbon and oil and gas, etc. It's also how we manage to protect our living planet. So there's something called, in the literature, the technical term is tipping elements in the climate system. The pop science term that we use is sleeping giants. And sleeping giants in the climate system are parts of the Earth system that once you push them beyond a tipping point, they tip irreversibly and destabilize the climate system. And there are several of these. I'm just going to give you 2 examples. One of them is related to sea ice. And the logic is quite simple in a sense that if you have a white surface, so imagine a big white surface, that has a particular something called albedo, reflective property, right? So if it's white, it reflects away sunlight. Now imagine that white surface becomes a little bit darker. So you see sea ice melting, and that area becomes dark. So what happens in that area? It becomes warmer, right? Because the albedo properties have changed. Once it becomes warmer, more sea ice begins to melt, which makes it a little bit more darker, which makes it more dark, which makes it more warm, and then you see more melting, becomes more dark, more warm, etc., etc. So that's the worry, that you trigger these sort of feedbacks in sea ice. The same with living systems. So for the Amazon and boreal forest, there's quite good evidence and insights that once you push these forests beyond a certain tipping point, through deforestation, through climate change, actually they would tip and become something very different and lose their ability to help us stabilize the climate system. Those are sleeping giants. And that's the new context. And you've seen, many of you, I mean, you've heard about the fires in the Amazon and deforestation in the Amazon, and I've done a lot of work on this in particular. The worry with the Amazon, it's not only about, it's not a local issue only. It's not only about local biodiversity or the rights of people. It's also the fact that the Amazon has an estimated tipping point at a 20-25 degree deforestation rate compared to pre-industrial times. And now we're around 17 to 18% of deforestation. Of course, there are many, many uncertainties around this. We don't know exactly. And it's not something that goes from one year to another. It's not a quick process. These tipping points, they might be very, very slow. But this is the worry around the Amazon. And to me, it's fundamental that we understand the Earth system, the behavior of the Earth system, to be able to talk about what should technology do for us in the future. So again, the same slide. So we're about there. That would be a leap into the unknown in a risky future. But then also, of course, at some points between 2, 2.5, 3, we might trigger and wake these sleeping giants up, and then they might by themselves push the climate system to high degree scenarios without us doing anything. It's just the Earth system responding to what we've done. So that's the context. To me, that's critical. Keep that in mind when we talk about tech development. That's the reality we're facing. So here's a little bit of a provocation. And it's not intended to you specifically, but just like in general. The thing is that we should have started our journey towards decreasing emissions long time ago. I don't want to bore you with the details of that particular graph. But if you think about how the climate systems behave and you look at our rates of emissions, if we had started in 2000, it would have been enough to decrease emissions with 2% per year to stay within a safe boundary of climate change. That's not a lot, 2% per year. Totally doable. The thing is that since we're delayed, so in 2019, we now need to decrease our emissions with 5% per year, which is slightly more difficult, of course. It's doable, but more difficult. If we continue to postpone action on climate change, let's say to 2029, we need to decrease emissions on average 9% per year. That becomes very, very, very difficult suddenly. Another way to put it, if we are to stay within a safe boundary for climate change for everyone, we need to halve emissions in the next decade, and then halve emissions again in the following decade, all the way to zero. And depending on how late we are in that, we actually need to start removing CO2 from the atmosphere actively. That's a massive, massive challenge in the context. My second part of the provocation, we knew this already. I mean, we knew this. We've known this for so long. Of course, there are much earlier papers on this and articles, etc. But the first synthesis of the IPCC where this was established was in 2001. So this was 18 years ago. The science was very, very clear already then. In 2006, this major synthesis came out by Nicholas Stern, where he and his colleagues showed that actually it made economic sense in all ways to address climate change. That was in 2006. We knew that. And one of the reports also came out around that time called the Millennium Ecosystem Assessment said the same thing. We're destroying biodiversity, ecosystem services at a rate that will threaten human well-being. Now, this was a major synthesis by thousands of scientists. So we knew that already. So no wonder that the next generation or young generation is upset and wanting change. And that's probably my favorite sign, because I'm also a little bit of an introvert, but it's so serious that I'm standing here right now in this huge theater talking to you guys. So the question for me, and I mean, my background is political science, but I've always worked very, very closely with people in the natural sciences, climate sciences, etc., and interested in technological change. What if we've gotten tech innovation all wrong, that we're thinking about tech innovation in the wrong way, the wrong direction, the wrong framing, the wrong goal, the wrong people, the wrong emphasis? I mean, I really want to raise that as a fundamental question that we all need to ask ourselves. And of course, when we talk about AI, artificial intelligence, and all the hype around artificial intelligence, and all this hype around it's going to help us optimize, it's going to help us have autonomous cars, etc., etc. To me, the key challenge, and I am optimistic, I think we can do a lot of good things with artificial intelligence and robotics, but how do we make sure that applications of artificial intelligence don't just accelerate the degradation of the environment that we're doing, that it doesn't lead to much more sophisticated spread of misinformation, and that it creates big social inequalities? What would it take to make sure that we create that direction? Personally, I'm worried about many things, but I think misinformation is going to be one of the biggest challenges for our community as the digital media ecosystem evolves in the future. And we see that so clearly now already. The early warning signals are there. I mean, you've heard about troll bots and social bots, etc., and the role of misinformation and disinformation in the US ahead of the US elections, etc. And there's more and more evidence that we're not really in control of what type of information is there online. So this is just one example. This is a YouTube search on should I get my child vaccinated? So this is probably one of the most investigated fields about mis and disinformation, and how easy it is to just get squeezed in through the recommendation system of YouTube into videos that are just full of misinformation, misunderstandings, etc. And we're seeing the health impacts of this already now. We're also seeing the impacts of, as I mentioned already, social bots. So social bots, just like a quick technical definition of that. So applications of computer algorithms that produce content automatically and interact with humans on social media. And the thing is, just looking at the percentages, this is a rough estimate, 15% of all Twitter accounts. The thing is that these bots are becoming so sophisticated that it's hard for a scientist to actually see what is a bot or not nowadays. It is difficult. There are very good tools online that you can use, something called the botometer, etc. But once you move into big chunks of data and a lot of users, that botometer gives you a lot of false signals. So it's very hard to tell actually what happens online. And we see that in the health domain, in the health sector. This is a massively interesting paper. So you know that in the US, vaccination is a big issue, very polarized. And this paper found evidence that there was actually counterintelligence operations from Russia into the US debate through bots to polarize the debate in the US intentionally. Another article that was published last year that looked into the Catalan election in Spain. You know, there's a big tension in Spain at the moment, that also showed the intentional use of bots to increase polarization and increase violence. So this worries me, and for a long time, we never saw that in the climate and environmental domain. That was just not an issue until September this year, when the UN hosted a big meeting, the UN Climate Action Summit, all the world's leaders gathering in New York to commit to climate action. And online what you see is a massive mobilization of trolls and bots trying to spread disinformation, add noise, add polarization. So to me, this is one of the biggest challenges we're facing at the moment in my sector. So here's a little bit of a call for action now, my last point. If we recognize that planet Earth without a biosphere is just a floating dead rock out in space, and that the technosphere will change our ability to reach sustainability, how to understand its impact? I think there are four main impacts that go way beyond optimization and control and autonomous vehicles. First of all, the technosphere, through big data, artificial intelligence, etc., it's going to change the way that we perceive environmental changes around the world. I think it's going to act as a filter for how we perceive that our planet is changing in a very deep way. The second thing is that it will fundamentally change and possibly augment our ability to get knowledge about planetary changes. So we will see causal patterns, we will detect early warning signals, we will see how things are connected in a completely different way through technological change. The third point, I think it will change our ability to respond to environmental change. So once we see bad things are going to happen, we can respond in a very different way through technology than we could before. And then the last point, I think it changes the way that we can innovate compared to before, the innovation pathways for the future. So this was a scary graph, right? I mean, it's a massive challenge for us. So in the next decade, we need to halve emissions, and the decade after that, we need to halve again, and then hopefully get to zero, and likely to be able to actively remove CO2 from the atmosphere if we are to stay within a safe climate change space. This is an innovation gap. And some people, a lot of young people that I know, entrepreneurs, see this as a massive opportunity to reinvent new business models, new technologies that will help us get there. And it's not just about reducing environmental stresses. The agenda is very different now. It's not just that we want to do less bad. We want to create innovations that bring something positive with them. So remove CO2, or actually innovate in a way that increase biodiversity, or increase freshwater flows, or increase what we call ecosystem services. To me, that's a new innovation agenda. And of course, we will see applications of artificial intelligence and robotics on things that are related to the environment. And I think they're interesting and intriguing. For example, we can use AI and other types of technologies to fight illegal fisheries. Of course, we can use mobile technologies to improve harvests, to boost and increase resilience in vulnerable regions. And of course, we can be clever in how we use AI to improve conservation, environmental monitoring, et cetera, et cetera. That's just applications. It is already now having a big impact on science. So nowadays, we can improve climate models through machine learning. Modern climate models will be much more predictive, much more detailed, way better through machine learning and deep learning applications. Environmental monitoring for science will improve through machine learning, that's for sure. And we will be much better in our ecological research through these tools. It would be a massive, massive augmentation of our work. So this is an opportunity. That's the way I like to see it. I have a lot of colleagues that work in the field of urban and the role of cities in the world. And what they note is that over 60% of the area that is projected to be urban in 2030 has not been built yet. So what if we get that right? There's an opportunity to get it right. Majority of that area that will be urbanized in the next decade has yet to be built. Let's make sure we do that in a very clever way. And of course, the same if you're an entrepreneur in the tech sector or creative sector or whatever, just think about the possible business opportunities that are there in that type of thinking. But of course, this is not something that happens by itself. I have no confidence that this is something that the tech sector will do by itself. I think you need direction. I think you need very, very clear incentives. So a while back, a number of colleagues and myself, so not just scientists, we had artists, we had programmers, we had a hacker, philosophers. We got together for one day, and this was actually before the whole hype around AI, and talked about creating something called the Biosphere Code. So what would be principles that we would like the world to acknowledge as they build new technologies based on big data and very, very advanced algorithms? So at that time, the word people used were algorithms. Nowadays, it's deep learning. And we came up with 7 principles. I'm just going to go through them a little bit quickly, but just to give you, like, what are the things that we need to acknowledge as we move tech progress forward? First of all, with great algorithmic powers come great responsibilities. That's nothing new now. In 2015, that was new, in a sense that if you are developing a technology that actually has impact in society, you have a responsibility. The second thing is that it's not only about social impacts, but it's also about the biosphere. So algorithms should serve humanity and the biosphere at large. That was the second principle. The third principle, the benefits and risks of algorithms should be distributed fairly. So any risks that our technologies are creating and the benefits that these technologies are creating should be distributed in a good way and not increase social injustice or discrimination. 4, algorithms should be flexible, adaptive, and context aware. And that was just to observe that we, as a species, are in a phase where our environment is changing very, very rapidly. So if you're creating a technology that works very well now, that doesn't secure that it will work well in the next 5 to 10 years because our environment is changing so quickly. And principle 5, to acknowledge that we're moving into an uncertain future with complex systems. In complex systems, there will be surprise. So be ready for surprise and make sure that we use data and algorithms in a clever way to detect that surprise. Principle 6, and this probably goes very well to Facebook and Google, etc. Algorithmic data collection should be open and meaningful. Obvious now. And then the 7th principle, and this was something that people got really excited about and thought this needs to be there, is about beauty and inspiration. So algorithms should be inspiring, playful, and beautiful. They should be used to enhance human creativity and playfulness and create new kinds of art. And of course, facilitate human collaboration, interaction, and engagement with each other, with society, and with nature. So this was 4 years ago. We talked about algorithms, but I believe, of course, I'm biased, they have aged quite well. I think we still need it. So wrapping up a little bit, I have no idea how long time I have left. But can technology really save us in this context? I think it can, but I want you to acknowledge something else. And this is an image. This is Ben from Uppsala. It's a small city north of Stockholm. He's one of the members, I don't know how big the group is, called Historians for the Future. You've heard about Fridays for Future. This is Historians for Future. And on his sign, you can read, large-scale social, economic, and cultural change can happen quickly. It has before. And mass protest movements are key to making it happen. I think that you need to keep this in mind. I think technology is going to shape our future. It's a massive, massive force of change, both in the way we interact, but also the way we interact with nature and the climate. But if you want to guide tech development, you cannot underestimate the need for people to shape that future. And this is something that comes very close to me. So I was born and partly raised in Chile. You've seen all the images from Santiago. You've seen probably burning metro stations, buses, supermarkets, military on the streets, etc. One thing that you should remember when you see images like that is that actually most of the marches that you see in Chile, and this is an image from the biggest one with over 1 million people on the street, have been peaceful. Very, very peaceful. And the thing is that how do you make sure that you get 1.2 million people on the street demanding social change in a peaceful way? I mean, people got together through a very old technology, we would say now, social media. That's how people got together. And to me, that is a key thing to remember. That even though technology will change the planet, I think in the end, it's not just technology, it's people. And people demanding things, people trying to guide things, trying to make sure that all these big technological forces are redirected into the right direction. So it's not just technology, it's also people together. And I'm going to leave you with that. This is a small video from one of the marches outside of the National Library of Santiago, people singing an old 80s song that has become sort of the anthem for peaceful protests and demands for a more hopeful future. So I think I'm going to leave you with that and just wish you a great festival and great next days here at Kikk.